Welcome back to another installment on linear, rational, and variable equations with solution. Let's get started. The first problem states, given the lines y equals 0.5x plus 3 and y equals 3x minus 2 intersect, what is the value of the point of intersection, right? This is not a logical assumption. This is actually true. When two lines intersect, the y values should be equal. So if you use that logic, then we can say if two y's are equal, then 0.5x plus 3 should be equal to 3x minus 2. If you solve for the value of x, you will see it's 2. Okay. I didn't go through the steps, but I'm telling you the value of x is equal to 2. So what is the y value? You are welcome to substitute x equals 2 in any of the two expressions. The y values will be the same. If you don't believe me, you can see me do it. So let's go ahead and substitute x equals 2 in the first expression. So it'll be 0.5 times 2 plus 3, that'll be 4, right? Let's go ahead and substitute y in the second expression. It'll be 3 times 2 minus 2, that's 4. Because the two lines intersect, the point of intersection should have identical y values. So y1 equals y2, right? So what is the y value of the point of intersection? That'll be 4. Okay. 10 gallons of paint will cover an area of 75 feet. How many gallons of paint will be required to paint the area of a rectangular wall that has a height of 8 feet and length of 24 feet? Okay, so for this problem, if you know the formula for calculating the area of a rectangle, you're almost 95% done with the problem. Then you have to do simple cross multiplication and get the correct answer. So we have area of a rectangle, okay, equals area of a rectangle equals length times width. In this case, it's length times height, right? Because it's given us height, which is the same thing. So our length is 24 feet and our height is 8 feet, which would give us 192 feet squared. 10 gallons, okay, can paint an area of 75 feet squared. So 192 feet squared would require how many gallons? All you have to do is 192 times 10 over 75, which is 25.6 gallons. Okay. If you're unsure if you did the math right, then you can do something, which is we know 10 gallons, okay, can paint 75 feet squared, right? So how many would 1 gallon can paint? That will be 7.5 feet squared, right? So 1 gallon can paint 7.5 feet squared. So 192 feet squared would require 192, well, 192 over 7.5, that's 25.6 gallons. You see, this is just a proof, or this may be the way you're thinking. This is one way of thinking about it. Or once you get this is another way of thinking about it. So there's essentially two ways of thought in the school. You're welcome to choose whichever one works for you. Some of you are probably thinking directly from a 10-gallon perspective. Some of you want to not think that way, that you just want to know what is it going to be for a gallon. From there, I'll work my way. I've shown both ways for both of those people. So let's continue. What number decreased by 7 is equal to 10 increased by 7? That's a very simple problem. So We don't know what the number is. Let the number be x. So only the first part of the problem talks about this imaginary number. The second portion of the question is not imaginary. It has a real value. So x is the number that we don't know. What number decreased by 7? So x minus 7 is equal to 10 increased by 7. So 10 plus 7. So x minus 7 equals 17. X equals 24. Okay, you have to learn how to read the problem. If you didn't understand it the first time, second time, read it, but be a little bit slower so you can actually see what the question is asking you to do. If 5 plus x is 5 more than 5, what is the value of 2x, right? If 5 plus x, okay, is 5 more than 5, that is 5 plus 5, right? So 5 plus x equals 10, x equals 5. What is 2x? 2 times x is 2 times 5, which is 10. Again, this is very similar to this. If 5 plus x, well, there's no reason to change anything. It's exactly the same and it appears the same. It's only the second part right here, 5 more than 5. You may be tempted to think it's 5 more than 5 times 5. That's incorrect. If it is 5 times 5, then they would say times instead of saying more. More means you're just adding a value, right? So that's how you do it. We have done this sort of problems under the functions category. So if you haven't watched my videos on functions, please do go and watch them. So f of x equals 2x cubed plus 7x squared minus 4x. We have g of x, which is equal to 4x minus x cubed. If k is a positive number such that f of k equals 0, then what is g of k? When they say the function is equal to 0, you're not substituting, 0 in for x values, okay? What that means is f of k would be, first you have to write the expression in terms of k. That's 2k cubed plus 7k squared minus 4k. When they say f of k equals 0, they're not saying k is equal to 0, the whole function is equal to 0. What that means is 2k cubed plus 7k squared minus 4k equals 0. Just take k out of the picture. So it's 2k squared plus 7k minus 4 equals 0. So when you have this sort of situation, we know k is equal to 0, so we don't need to worry about that. So let's go ahead and do factoring of this quadratic expression, which is 2k squared plus 7k minus 4 equals 0. This is 8k squared, so we have to multiply two terms. That'll give you 8k squared, but then when they are added or subtracted, it will give you 7k. So essentially, if you take 8k plus 8k and minus, we have to get negative 8k squared. So if you do this, then you get negative 8k squared. And at the same time, if you add these two terms, then you get 7k, right? So substitute this in place of 7k, which would give you 2k squared plus 8k minus k minus 4 equals 0. If you take 2k out of the bracket here, it's k plus 4. Minus 1 would give you k plus 4 equals 0. So it's 2k minus 1 times k plus 4 equals 0. So that means k equals 1/2 or k equals -4, but we're told k is a positive number, so k is not equal to -4, k equals 1/2. So what is g of k? G essentially is g of 1/2, and we know g of k is 4k minus k cubed, right? So g of half would be 4 times 1/2 minus 1/2 cubed. So that's 2 minus 1 over 8. Implies 8 would be, this is 1, so 16 minus 1 is 15 over 8. It's a very easy problem. Again, I've done a lot of problems on functions. Please go through my playlist on functions. You'd get a better understanding of many of these concepts, right? So let's continue. This is a pretty tricky problem, and I must say this is also a very lengthy problem. So please stay with me. And if you're unsure at any point, just watch through the video and go back and watch it again. You'll get it, right? Sum of two consecutive positive even number is 2 greater than 1/10 of the product of the two integers, right? We don't know what the integer to begin with, so let's say x. The first part of the question says sum of two consecutive positive even integers. So if your integer had been 2, then the next positive consecutive even integer is 4. So if this is x, this is x plus 2, right? So that's what you have on one side. So x plus x plus 2, okay? Sum of two consecutive positive even integer is 2 greater than 1/10 of the product of these two integers. So x plus x times, right? 1/10 of the product of the two integers. So x times x plus 2, right? Let's keep all of these in as many brackets as possible, right? Now, if you do this side, so it'll be 2x plus 2, right? Equals 2 plus 1/10 of x times x plus 2, right? If you multiply by 10 on both sides, then you get 20x plus 20 equals 20 plus x times x plus 2, right? So that'll be, what is it? These 20 cancels out. 20x equals x squared plus 2x, right? Right, and then you can bring it all to one side. So x squared minus 18x equals 0. You take x out of the bracket. Again, I've done similar problems like this on my factoring videos. Please go and check them out. So x equals 0 and x equals 18, right? Sorry, and x equals 18. We're asked, we're not done with the problem. We're asked, what is the sum of the positive factors of the smaller integer, right? We are told positive. So 0 is not positive. So the only positive we have is 18. How many ways you can get 18? 18 can be obtained as 6 times 3. 18 can be obtained as 9 times 2. 18 can be obtained as, what other ways you can get? So, we have 6 times 3, 9 times 2. Well, we can do 18 times 1. So 6 plus 3 plus 9 plus 2 plus 18 plus 1. Okay. You can also do 18 times 1. And then I'm thinking, I don't think there's any other way. So let's go ahead and add all of these numbers. So 6 plus 3 plus 9 plus 2 plus 18 plus 1. So that's 9 plus 9, 18, 20, 38, 39. So there's really two big holdups in this problem. So let's look at the elephant in the picture, which is this. If you cannot conceive, and I think I've mentioned this once before, if I can do it, I'm sure you can do it. Maybe it's taken me three steps to 3 times or 4 times to understand it. It may take you 5 times or 6 times, but eventually you will get it. If you see me write this and you can't do it, then you have to think, where can you not do it? Can you not just write the expression at all? Or can you write the left side and you have written maybe 60% of the right side? Then you need to know, okay, that means I've got almost 80% done. Why can't I think 20%? Your best bet would be to not watch this particular problem at this point. Watch it another time, but don't see me work out the problem. Just pause the video and see if you can recollect your previous knowledge and do your best and see if you can surpass your 80% of efficiency prior. If you can get it 100%, that means your brain has started to put things together in a way that it's supposed to go. That means you're comfortable with doing this sort of problems, right? This is a simple problem. And I think the second obstacle that I mentioned is this: when they say factors of the smaller integer, that means you're not doing factoring of this sort, you're just factoring the number itself, how many different ways you could get the number. Okay, that's essentially what factoring is, how many different ways you can break something into pieces. And when it's a quadratic, you break it differently. When it's just a number, then you have to figure out how many different ways you can piece it together so you get that number. And that's precisely what I did. Once you've gotten that far, then you just add all the numbers and you get the final outcome, right? Thank you for watching. I'll see you with another video on linear, rational, and variable equations with solutions, right? So please stay tuned.